Hello and welcome back. This week we're going to be talking about design patterns and design patterns within code and architecture. We're going to talk a little bit today about just sort of introducing the idea of what they are, when we need to use them. We've sort of hinted at a few of them already throughout the course, so that's always a good starting place. And then we'll continue with this discussion throughout this set of lecture videos this week. So let's jump right into it. Let's talk about design patterns. And design patterns are not just recipes for code. It's about designing our code in a smart way. It's not about copying and pasting code in a specific sort of structural format. These are proven solutions to recurring design problems. So things that go wrong in our code, these are ways to help us sort of solve them. And we kind of will be describing them in terms of the context that they're used in, the problem that they that occurs when they're not being used, as well as the solution, so like how this solves the problem, right? They have nothing to do with specific programming languages or frameworks or software, anything like that. It's totally conceptually separate. They're not snippets of code. They're not like cool ways to write code. This is how we should be writing code. This is like the mandatory baseline for what we should be doing. They were popularized by the Gang of Four in design patterns, elements of reusable, object-oriented software. It's a text that was defining these different design patterns. Now we won't go through every single design pattern in this course because there are tons of them, but we will see many of the frequently used ones. So let's start with the different pattern classifications. So these themselves are not patterns. These are the different classifications of patterns. If you want to imagine it like a hierarchy, this is like our superclass. This is our interface. So we have creational patterns. These ones focus on object creation, which makes sense. If we have lots of different objects or complex objects that are being created, we need some patterns as a way to sort of focus in on how we design and structure our code. Its job, these types of patterns typically are in charge of controlling when objects are getting made, as well as how we are creating them. So at the start of this course, you were very focused on anemic object models, basically just getters, maybe a couple setters, but probably not. And now we're going to discuss ways that maybe we can start to build out our code in a sustainable way around object creation. The next pattern classification is structural. This is when we are looking to basically simplify our relationships between objects. So we're actually talking about how we're structuring all of our code as a whole, and if we have multiple objects talking to each other, how can we design our code in kind of a sustainable way? So this is about organizing and connecting components in a clean way. You can also think about this as like coupling and cohesion, composition versus inheritance versus aggregate, the different ways of sort of our code pieces interacting with each other within the space. And then lastly is our behavioral pattern classification. This one has a focus of organizing the communication between the objects. So many of these, of course, are all working together, but behavioral is the ones that allow us to sort of define the clear interaction between our different objects. So they help us define the patterns in which we want to connect our code, how we want our objects talking to each other. So just like everything else in this course, right, I've said it many times, we're talking about giving you tools that you keep in a big conceptual toolbox that you can now use when it is appropriate. So you can use them anytime. You use them when they make sense, when they fit. If you find yourself writing the same logic over and over again in one place, like don't repeat yourself or open close principle, there's a good chance that one of our design principles can sort of help solve this problem. If you want to reduce dependencies and make changes without breaking them, so we've got like coupling, single responsibility principle, or the principle of least knowledge, also known as the law of Demeter. I've mentioned it before, even though it wasn't written down. Pardon me. Another great time to use design patterns. If we want clear communication between parts of our system, so if we see that we have more principle of least knowledge, principle of least astonishment, dependency inversion principle violations, coupling, cohesion violations, this is a good time to employ a pattern. Or if you want to add some new features without rewriting large sections of code. So there's patterns that are specifically made to, or are specifically defined, I should say, to help us in scenarios where we have lots of code that already exists, and rather than refactoring all of that, but we want to add something new, we can employ certain patterns to sort of bring all this together, bring this idea together. So when we've got coupling or cohesion concerns, open-close violation concerns, Liskov substitution, or the interface segregation principle concerns, right? So this isn't all the indicators that might tell you, oh, a pattern, like let's try and implement a smart design pattern here, but these are some of the most common indicators that I've seen, certainly in these projects and in the industry. Now, just like, again, I say it 1,000 times, if I give you a hammer, not everything needs to look like a nail, right? So there is a warning associated with these patterns. If you use them everywhere, the beauty of them goes away. They just become code soup, right? We just have it all over the place. We need to be really careful and cognizant that we're not building a rocket ship if all we need is a bicycle, right? Keep it simple, stupid. That doesn't mean don't plan ahead. That doesn't mean don't have those conversations, but we want to be really cognizant of the decisions that we're making when it comes to writing our code. So there's this danger that if we overuse patterns for situations where we just don't need them, our code actually gets harder to read, right? We mix too many patterns in one place and our code is just pattern soup. We end up over-architecting, so we're adding complexity, but it didn't add any benefit because our code didn't need to be that complex, right? This can slow development. This can confuse maintainers, confuse yourself later on, right? It makes debugging harder. Just because these exist doesn't mean that they're exactly what we want to be using all of the time. So we always want to make sure that we're starting nice and simple with these. We're going to refactor into a pattern when we see a recurring need. So just because you wrote it the first time doesn't necessarily mean as you're writing it, you stop. It's the very first time you're sitting down and you decide you need a complex pattern. Sometimes, very often, these are birthed from technical debt, right? So when we see the same problem occurring and we go, oh my gosh, if we rewrote this, we could write it so beautifully using this type of pattern, right? So we want to start simple. We only want to refactor into one of these patterns if we actually need to. We want to make sure that we're matching the pattern to the actual problem and not the other way around. We don't want to take a pattern and try and force it into our code if the problem doesn't exist, if the need isn't there. So it's very important that while we're going through our code, if we see a potential problem, that we can sit down and talk about how might we be able to solve this and what patterns might best be able to help us with this. All right, so we've talked about this one already, but we're going to give it a little bit more concrete definition. So we've discussed this idea of replacing a switch statement before. These can keep growing. They get really messy. They can be difficult to follow. These are basically just walking open-close principle violations. So how can we actually solve this problem? Well, we've actually discussed the strategy pattern before. So what do? We're going to make an interface. We're going to take all of those calculations and put them into classes, each one responsible for its own, and then we can make a shape calculator with composition right here, where we can actually calculate it based on whichever one of these we are required to use. So this is our strategy pattern, and we've seen it before. So now, how is it that we're going to actually make each of those shapes, right? So previously we had got a number in and a shape type, and we matched our shape types to the different values, and we returned the calculation. And the hardest part for people to sort of wrap their head around is that what's coming in is like an int for a shape type, or the string, circle, square, rectangle, whatever. So how is it that we're going to take that input and turn it into an object? Here, we can see we're still doing a switch, case 1, case 2, and possibly more, right? But this is actually known as a factory, and it's another type of pattern. This is our factory pattern. And there are ways to sort of register our factories and make it even cleaner, but this is a completely legitimate code snippet. So even though we still have this switch statement, we can see now that whenever we add a new type of shape, we're not actually having to do switch statements wherever behavior is occurring. We're only going to have to alter the creation of a new shape. And that actually makes perfect sense. It makes sense that if we add a new shape, the factory assembly needs to also change. That makes sense. It doesn't make sense that we would have to change every single other type of calculation around our new shape or every other type of behavior. I'm trying to think of a really good example with like in a calculator, if a new number was discovered or something like that, I don't know, a new type of operation was discovered, math people, I don't know, and we have a calculator, we should be able to bring that in, and how it interacts with the rest of the code can be sort of all enclosed in this new type of operation. We still need to be able to register that new type of operation and create it. So there is still going to be a situation where we say if they push plus, if they push minus, if they push our new mystery operation, right? That's still going to exist, but we've now centralized the creation, and it's separate from our behavior, and all behavior is encompassed within each of the different operations. It's not the worst example. Okay, so I'm going to show you a website here, and I want you to potentially spend some time reviewing these guru patterns and see if you can find one of the patterns that might have helped make your code or a feature you recently implemented a little bit cleaner and easier to use. You should sit down, you should pick one, you should ask yourself, how does it help? And you should discuss with your group on whether or not it makes sense to go back and refactor your code. Like I said, we will be going through in these videos some of the design patterns, but certainly not all of them. So there is some responsibility on you to go check out this website and check out the design patterns. Before I say bye, I am going to show you that website. So the website is Refactoring Guru. You can see that we have a couple of different links here. We've got Refactoring Guru, we have design patterns. If we click design patterns, we'll see that it opens up into the whole catalog. All three of our different pattern classifications are listed here in the sidebar, or you can just go through, all of them. You click catalog and you'll see them all. You'll also notice that there is a code examples button for different languages. So if you want to pick a language, pick one of the different patterns. You can learn a lot more about how each of these work, see an example of how they're implemented and how they solve the problem that each code snippet is presented with. Really, really helpful website. Spend some time perusing it so that you can make really smart choices in your code. And with that, I will now say thanks so much, and I'll see you in the next video. Bye.